Hello everybody and welcome to a chat from the engineering desk. Hope you're well. As you can see, we are playing with EDM, electrical discharge machining. In this case it's reactive EDM which is being done here. So the graphite electrode has got a electromagnet that pulls it away from the workpiece when current flows. The circuit is broken and then the electrode touches the workpiece again, current flows and it draws it up again, so it sits there buzzing as it were. And in the process the machining of the part takes place, or the erosion of the point where the electrode is touching the metal. In this case I've got a graphite electrode. One would usually be using copper. So here you can see the relay which I'm using as an electromagnet to work my electrode buzzing away. It's sitting there quite happily buzzing. This was a quick thing that I threw together as a demonstration to play with it. I learned something about it for myself, firstly, and make a video that I could share with you guys, which is hopefully something interesting. It's something useful if one wanted to do some EDM. One could work on this technique to set up a guide. You could also use a copper electrode. You'd obviously need to use the right dielectric. I just used tap water, but you could use distilled water, and you could use kerosene. You could have filtration for your dielectric to keep it clean, or you could have magnets in the dielectric to catch the debris that's coming off the machining process and keep the dielectric clean. Depends on the size of what you're doing, the scale of what you're doing, and so on, whether it's something you do for yourself or commercial application. So there you can see my electrode has started to form a mark on the nut, and you can also see some electrolysis taking place due to the fact that I've just used a bit of tap water. My bottle of distilled water turned out to be fairly conductive water for some strange reason, so I just opted for tap water. The problem with your dielectric is that it has to be very non-conductive, because otherwise current just passes through the relay continuously and your electrode remains pulled up, which is obviously not what you want. That's something I learned here and I'm pointing out. It's something we can share. So here's our nut. We're at the end of the recording that I did for the demonstration purpose, and you can see where the black mark has formed. There's now quite a bit of metal that has been removed, and that's pretty much where I ended the demonstration over there. Next I'm going to show you a photo of what the tank looks like, how I set up the relay over it, and then we're going to talk about the electrical circuit. So there's the tank with the relay suspended over it and a crocodile clip. Next is our schematic. It's a power supply, a relay, a diode, a capacitor, and then our connection to our workpiece. So there's the power supply up at the top, just a DC power supply. I used a variable one. Got our relay, which was a MY4 relay, it's ordinary relay, a freewheeling diode across it, and then down below the capacitor across the workpiece, which stores a charge which releases current into the workpiece and causes your discharge to happen that erodes the metal and does the machining for you. That's how EDM works. So that's the end of this talk. Hope you enjoyed it. Hope you learned something from it. Maybe try it. Maybe a professional who sees this can share some experience. Comment down below, we'd love to hear from you. It's always nice to have people in the chat. For the rest, have a wonderful day further, folks. I'll see you here for the next one. Cheers.